So it's with great pleasure that I introduce Cecilio Banner and Maria Manxton for the presentation on the air taxi. You're recognized.
Thank you very much, Mr. Chair and members of the board. Wholeheartedly good morning from Europe. Thanks for having us. You know that we are exploring in quite a few geographies around the globe, but Florida has grown dear to our hearts, so we're very sorry about the situation. We are very sorry for not being able to be there in person, but we hope we can catch up in person with you as a board as soon as possible, actually, once the situation will have changed. Thanks a lot also to Christina. I think that was an outstanding study and what a job, right, especially with respect to air taxi. You know, many of the manufacturers are still very much in stealth mode, and I think it's really hard to look behind what's in there. We will open up a bit today. And at the same time, there's also a huge variety in the market for electric air taxis. You outlined the 3 different kind of concepts that are out there. Lilium clearly is a vector thrust, and it comes with a few actually unique selling points and specific performance criteria of the aircraft. So thanks for that, and maybe to avoid a few misunderstandings that are quite common actually, maybe want to highlight observations at the beginning before we deep dive into individual charts and analysis. The first is that the Lilium service is possible in existing regulatory frameworks. We have been for years actually liaising very closely with FAA, both on the federal level as well as on the local level. I've been actually chairing GAMA's eVTOL committee, which is the Global Aviation Manufacturers Association, for quite some time now, and there is a very close liaison actually with FAA and an understanding that especially the Lilium service, where we have the capacity to transport 5 people, so including 1 pilot physically on board, and where we can, with a very high safety level and level of precision, actually operate into aerodromes of different kinds, can take advantage of the existing so-called rules of the air. We will be registered as a regular airline. The pilots will be fully certified as CPL pilots, and the aircraft obviously will be traditionally certified by the authorities, in your case, FAA. Second, our service is highly meaningful in terms of throughput. What I mean by that is that, you know, given the high speed of our aircraft, which is up to 185 miles, and given, again, the 5-seater configuration, we can transport many, many people on a single vehicle, as small as it might be, and through a single piece of infrastructure. So if you think of the St. Pete's Tampa example, and Marie of my team, who will cover substantial parts of the presentation in a minute, actually will deep dive into that. If you think of such a connection, we can actually turn around a few times in an hour, so transport maybe 10, 12, or even more passengers on a single vehicle within 1 hour, whereas the taxi, we all know that on average transports some 0.5 passengers per hour. If you think even bigger, and that's only possible on basis of very few of those eVTOL aircraft, but in our case it is, if you think of Tampa to Orlando, for example, you could do it maybe 1.5, maybe 2 times per hour on average. So this means, you know, 6 or 8 passengers, and this is even more powerful in terms of, you know, 400, 500, 600 passenger miles per hour that you produce on a single vehicle. So it's meaningful. And the third, and that obviously is closely related to the second, is that air taxis actually, especially if they come with the requirements and specifications of our aircraft, are among, if not the most efficient means of transportation if you look at it from a global economic perspective. What I mean by that is that you can do this Orlando-Tampa connection and everything else in our radius of operational range on very, very lean infrastructure, right? The paths that you would need in the respective cities, A and B, are extremely lean in terms of surface consumption, so also from an environmental perspective, as well as financially and from a cost perspective, and you don't need any connecting infrastructure in between. Also, if you compare our throughput, which already on a small pad that could be established on a rooftop, for example, if you compare that, which is a few hundred passengers up to 1,000 passengers per hour on such a landing pad, if you compare that per square meter or square footage versus how many passengers are being throughput in a large international airport, let's say LAX or Chicago, we outperform them actually by 100 or even 1,000 in terms of passengers per hour and square meter. So this is from a cost, from an environmental perspective, and therefore then in the end also a price and customer satisfaction perspective, obviously among the most efficient, if not the most efficient vehicle in the market. Progressing maybe with the presentation, and I don't know if only I had lost it. Actually, we wanted to cover thanks a lot. We wanted to cover 3 chapters. One gives you a bit of an overview of what Lilium is, where we stand as a project, what we're doing. Second is focus on the aircraft, how it's operating, and why it's so safe and so fast. And then thirdly, and mainly, is the application in your case, how such a service could look like along the west coast of Florida and beyond, almost across the whole state. Lilium recently celebrated its 5th anniversary. It was in 2015 that actually 4 aeronautical engineers found together at Technical University Munich, all of them in terms of PhDs and master's degrees, focusing on propulsion technology, which is really kind of the secret recipe of the success and the efficiency of our aircraft. And what started as a humble team in the famous startup garage setup has grown to actually the largest eVTOL developing entity in the world, even if you compare to projects like Boeing, Bell, or Airbus, with 500 employees actually. Despite COVID in the past few months, we've hit actually 400, 450, and just this week actually welcomed the 500th employee to the project. We do that on basis of a very solid funding, and you see a few of our investors in the line at the bottom. This includes the CEO and founder of Skype and his equivalent, Andrew Beebe from Twitter, who have invested in us early on. Funding has reached almost $400 million by now. And the team has not only grown in size actually, but very much also in terms of depth, especially over the last 1.5 years maybe. I think it's quite impressive in terms of how aviation and how experienced aviation our project has actually become. A few colleagues that we may want to highlight here. Top row in the middle, Yves Yancey, he was actually the number 2 in the A350 program by Airbus, leading quality for that program. Quality-wise, A350 is potentially among the strongest aircraft in the market. Below him, Brian actually was also number 2 in his capacity as COO of the Eurofighter program. To his left, Dirk Gebser, who's been leading the A320 manufacturing with Airbus. So every Airbus A319, 20, 21, 21 Neo was basically produced and manufactured under his watch, 3 such aircraft per day. Then he left Airbus. And many others, including colleagues from Boeing, NASA, and Raytheon, several other established aviation players. Unless there's any questions at this point in time, maybe moving on to the fun part of it, which is obviously the aircraft. And we had introduced and unveiled that last year, about a year ago, actually, to the world in terms of our fully electric 5-seater aircraft, which hits all our operational and meets all our operational specifications. The concept is quite unique. Christina was alluding to that in her study already. 36 fully electric ducted fan engines, almost perfectly centered around, distributed around the center of gravity of the fuselage on, in layman's terms, 4 wings. So it's 2 wings and 2 canards. And they are seamlessly tiltable, basically. So when taken off, the engines are fully directed to the ground, and then they can, tilt up to 90 degrees backwards. And therefore, already after having, climbed to a few meters, maybe 15, 20 feet of an altitude, what we call transition is actually being performed. And with that kicks in basically or kick in all the effects of wing-borne flight physics, right? And this is why our range with the 185 miles on a single battery charge, and why our speed parameters, also 185 miles per hour, and we reach them very, very quickly after takeoff, are so different from almost everything else that you see in the eVTOL market, because 95% plus actually of eVTOL projects are copters, and they come obviously, as Christina was pointing out in the study, with a very limited, not only range and speed specification, but also in terms of payload. Typically copter projects have the payload for one pilot and one passenger. That has obviously tremendous implications on the throughput, on the utilization, and on the pricing. But only on basis of the numbers that are highlighted at the very beginning in terms of the 4 passengers being pooled, and very smart city, fully electrically, on demand, in a pooled fashion, being put to the destination together. Only on basis of that you can reach really economics of scale, and also a price tag that is non-exclusive, but what we call very democratic in the end, in terms of it will be roughly around taxi pricing. Marie will deep dive into that in a minute, at launch of operations, and then even decrease over time when we take the pilot out of the cockpit after a few years, and then the networks will get densified. A few facts and figures as to the aircraft, some of which I've already mentioned. I think 2 are absolutely important for you as a board in terms of the safety and in terms of the acoustic profile of the aircraft. And for actually exactly those 2 dimensions, we have highly optimized the design. This is why we don't believe in open propellers. This is why we shield off every single of the ducted fans. So actually none of the components of the ducted fan in terms of a blade loss scenario that we would know from helicopter operations could happen. And at the same time, we are using actually A350 similar technology to shield off and absorb a lot of the acoustics already within the engine, so they are not being emitted neither into the fuselage where the passengers sit, nor to the outside. So already the 5-seater demonstrator that we currently have operating, as you saw in the video, actually could be put inner city. So not only operate from airports, even in a place like Europe that is totally not used to inner city helicopter operations. With that comes also, last sentence from my side, the very high safety level. This is a so-called 10 to the minus 9 safety level, which means what the regulator calls catastrophic events in 1 billion flight hours, as opposed to typically helicopters need 10 to the minus 6, which is in 1 million flight hours, and therefore roughly 1,000 times less safe. You will ask, where does it come from? It comes from us being electric. We can afford to leave many components out, so they can't fail if they're not there. No gearboxes, no oil and water circuits, many other things that you also know from electric vehicles, partially no aeronautical control surfaces in our case on board, so you don't have to maintain them as well. Makes us cheap in operations and for the customer.